Today we will be discussing unit number 2.2 in the solar PV installation course. So unit 2.2 is covering the batteries which are used in a PV system. So batteries, why do we need a battery? That is because in a standalone system, means a system which is not connected to the grid, there necessarily we need a battery because solar energy is not available throughout the time. So in the absence of solar energy, this battery is supposed to supply energy to the load. And this battery will store energy when the solar availability is there. Solar PV system is generating the electricity. In that duration, it is storing the energy. It is charged. After that, in the absence of solar energy, this battery will supply the load. So this makes the supply to the load continuous. In case if our system is grid connected, in that case, mandatory we don't need a battery because during the absence of solar energy, we can purchase power from the grid. Okay, whereas in case of standalone system, we need a battery to make a constant supply to the load. The battery, that is a cost wise, it is expensive, and its life, that is the shortest as compared with the other components in the solar PV system. It also requires proper maintenance. If maintenance is not good, then also the life of the battery that continuously decreases, battery get damages. In this figure, the main components of the battery that are shown: cathode, anode, then grid plate. Between the plate, there are plate separators. After that, the electrolyte, that is sulfuric acid. Okay, this is commonly used type of battery. We will be discussing about it later. That sulfuric acid electrolyte, where we are using it. So components: anode. So anode is the positive terminal, positive node, or the positive lead. It is the electrode which gives electrons to the external circuit, as a result of which electrode is oxidizing during the discharging reaction. Discharging means when the power from the battery that is being taken to the load. That's the discharging period. So it is, and next thing is the cathode. So it is generally referred as negative terminal or negative node. So cathode, it is the electrode which gains electrons from the external circuit, as a result of which the electrode is reduced during the discharging reaction. Means electrons are being received at the cathode. Another component is the electrolyte. So it is a medium which provides conductivity to ions between anode and cathode. Means ions are flowing between anode and cathode, and electrolyte, it provides conductivity. So electrolyte is a medium through which current flows internally in a battery. So externally the current is flowing through the load, internally through the electrolyte from anode to cathode. Then electrolyte is typically liquid. So water could be there, other solvents like dissolved salts, acids, or alkalis. They could be used as a electrolyte. One more component is there, that is the salt bridge. Basically, it is a separator. So salt bridge is a porous material used to keep the two electrodes connected, but yet separated from each other. Otherwise, the chemical reaction would stop. So salt bridge, that is also known as separator. Now coming to the type of battery. We can classify battery on the basis of chemical used, on the basis of presence of cap, on the basis of power output. And we will be discussing each type in a brief. The first is on the basis of chemicals used. So non-rechargeable batteries or primary batteries, and rechargeable batteries or secondary batteries. On the basis of chemical use, two types: non-rechargeable and rechargeable. On the basis of presence of cap, then open cell or flooded cell battery. Next one is maintenance free or sealed battery. And third, on the basis of power output, deep discharge battery and starting battery. These two, non-rechargeable battery and rechargeable battery. So different type of batteries, non-rechargeable batteries. So carbon zinc for the heavy duty, alkaline, lithium cell, silver oxide cell, zinc air cell. So name gives an idea, non-rechargeable means we cannot recharge it. It means in the application in solar PV system, we cannot use a non-rechargeable battery. We need rechargeable battery. So they are like lead acid battery, nickel cadmium, nickel metal hydride, lithium ion polymer. Most commonly, we are dealing with these rechargeable batteries in solar cell, mobile, laptop. Okay, because we can recharge them. Now, few features of this type of batteries: open cell or flooded cell battery. So they have caps on the top. Means we can open the cap and we can test the cell and add water to that cell whenever needed. If the water is going down, okay, like the electrolyte just we discussed, liquid. So we can add it, but not any type of water. Only pure distilled water is supposed to be used here. Otherwise, the impurities they will start accumulating. Okay, second one, maintenance free or sealed battery. So we cannot open this. So they are sealed. We need some type of maintenance, then we have to visit proper workshop or factory. Because we cannot fill the water there. Okay, they can be used for PV system. Okay, their life is less than open cell battery. Okay, if provided if the open cell batteries are properly maintained, maintenance is good, then open cell battery will last longer. To deep discharge battery. So these are suitable for PV applications, like in our case, because they are specially designed to deliver high percentage of their power without any damage. There's 80% of the stored power that can be used, that can be supplied to the load. And last one is the starting battery. So we used it for vehicles, for starting of vehicles. So it provides high power for a short time. Like we want to start engine. So only during the starting, this battery will provide a high torque or high power. They're easily damaged by using a percentage of the electricity stored in them. So we cannot use large or draw large percent of the stored energy. Battery that requires proper maintenance. The liquid level that should be monitored. If it is low, then we need to add distilled water and make the water level up to the required mark. Parameters. Standard parameters of the battery, like the battery terminal voltage specified in volt, charge storage capacity, that is coulomb or ampere hour. Very commonly we use the term ampere hour, AH, in commercially when we are using a battery. State of charge, depth of discharge, that is in percentage, how much percent. Life cycle, then self discharge, that is also in percentage, and the last, that is efficiency. Now we will be discussing each one of them in brief one by one. The battery terminal voltage. So battery, so whatever load that is being connected with the terminals, then the energy is supplied to the load. So the electric energy transfer from battery to load is possible only when there is voltage difference between the two terminals. So there should be a voltage difference. Thus, the battery terminal voltage is the voltage difference between the two terminals. Okay, so whatever is the difference between the voltage in the two positive and negative terminals, cathode and anode, that is the battery terminal voltage. And this causes the current flow in the load. Because each battery is made up of cell, so the terminal voltage of cell is determined by the components they are made up of. The battery terminal voltage changes with the condition of battery. It increases when the battery gets charged and decreases when the battery gets discharged. So voltages, different voltages used in the battery. So open circuit voltage, open circuit, no load is connected. Then whatever is the voltage between the terminal of the battery, that is known as open circuit voltage. Now operating voltage. So in the first case, that was open circuit voltage when no load was connected. In case of operating terminal, we connect the load, then we measure the voltage. So usually there is a very less decrease, means normal terminal or the operating voltage is less than the open circuit voltage. So this could be 1.5 volt for a small cell, 3 volt, 6 volt, 12 volt, 24 volt, 48 volt. So normally up to this operating voltage, the batteries are available. Cutoff voltage. Okay, this is the voltage to which the load operates and below which the battery should be disconnected from the load to prevent over discharging. Okay, means if a battery reaches this cutoff voltage, then the load will be disconnected from this battery. Battery storage capacity. The capacity of a battery that refers to its charge storage. So it is expressed in ampere hour. So capacity, that is a product of current and the time. Okay, so how much current or the charge? Okay, the unit ampere hour that indicates the amount of charge that is delivered when a current of 1 ampere is used for 1 hour. So the amount of charge given in the duration will be 1 ampere hour. Okay, so the rechargeable batteries from low ampere hour to thousands of ampere hour are available. The state of charge. The state of charge of a battery refers to the percentage of its capacity that can be used. Means how much percentage of the total capacity that can be used. So capacity, the charge storage capacity, that is 100 ampere hour. Okay, but it is depleted by 20 ampere hour. Then state of charge will be 80%. Okay, so that is the percentage of capacity which is being used. The battery state of charge, how to measure it? So we just need to measure the voltage, present voltage in the battery, and then compare it with the voltage of the battery that when it was fully charged. So whatever is the difference, that is the state of charge. Depth of discharge. So how much amount of power from the battery we can use? Okay, like the depth of discharge is marked as 25%. Okay, and the capacity, that is let us say it is 100 ampere hour. So how much how much amount of power, the energy that we can use? So 100, it is not 100, it is 25% of 100. That is 25 ampere hour will be available for us to use. So all batteries, almost all batteries, in case of renewable energy appliances, get the rating as per their capacity. However, the real energy that can be obtained from the battery, again more specifically for lead acid battery, is much less than the given rated capacity. Okay, because if all of the charge energy that is being taken from the battery, then its life will be reduced. Okay, so the percentage of maximum capacity of the battery is the percentage of its capacity that has been discharged. So a discharge of minimum 80%. Okay, is known as of DOD, that is known as deep discharge. Okay, so normally deep discharge batteries are preferred for photovoltaic applications. Okay, so about 50%. So full 100% depth of discharge, that is not available. Okay, so we have about 50% like that, or in case of lithium ion batteries, the depth of discharge that is 80 to 90%.